markets and safety, security, and defense in their 3D implementation of city models. So let's get this PowerPoint to where it'll move. I love 3D cities, and CityEngine makes it easy for anyone to create massive 3D urban environments on the fly. With CityEngine, you can quickly recreate existing cities to where they look fairly realistic, if not close to realistic. You can create your city of the future, or even that fantasy city you've been dreaming about. CityEngine can model environments ranging from virtual to real-world environments at small to city-wide scales on offline real-time rendering systems for ground-level or aerial city views, and is abstract to photorealistic visualizations. What you're seeing are several examples of use cases where it has been utilized, such as this military video that was basically created by Thales a few years ago using CityEngine for the Middle East. And then some other pre-scripted building growth automation rules that can be done in CityEngine, Python, as shown in this video here. So you may be wondering, how can I leverage CityEngine in my own projects? So let's discuss a few potential 3D modeling workflows using CityEngine. As with every design project, there is a conceptualization phase, and CityEngine is utilized at this project stage to sculpt and manipulate terrain, sketch basic roads in your area, and test land use densities and building types to make your city fairly realistic for your use case. Often in productions, a 3D model only looks or feels like a real city is required. And these so-called atmospherically correct city only mimic the architectural style of a building, shape, and facades. But a building does not correspond exactly to a real-world opponent, so to say here. Often productions do not have access to corresponding building shapes and geometries, nor do they want to buy the expensive building footprints. So as a consequence, a typical modeling strategy to reconstruct existing cities at low cost would be to take street data from, let's say, OpenStreetMap.org, which is open source, and a satellite picture. These can be photoshopped, or they can be actually real-world data from a real site. That you can generate blocks from the street data and procedurally subdivide the blocks into lots to roughly the same size, basically, as what you'd have on your satellite picture. You could write simple rules which generate the shapes and textures of the facades, and you can texture those with photos or a few buildings common in the city, such as what you're taking place at. You can control the generation process via image maps to fine-tune, for instance, land use, open spaces and green spaces, or to insert trees and other assets. And you can manually place landmarks at the right places within the scene. Such a generation of appropriate buildings in combination with the manual placement of landmarks makes it sufficient for bird's eye applications such as helicopter flight simulators. So the left picture shows you the satellite picture of OpenStreetMap data that's been brought into CityEngine. And the one on the right has been generated from that information. So to give you a better idea of what you can accomplish with CityEngine with the story phase. And last but not least, city model. Once the function and story is set, it's time to further detail the structural geometries. These could be refining the facade, the character of choice, creating destruction on the slide that we'll show you here later in a live demo, further modeling the streets to more accurate representations of your environment of choice as well. Basically, refining and texturing a lot of the model can be done at this part. You then also add the appropriate placement of 3D assets such as street furniture, people, cars, trees, and homes. And David Burdick will also be talking about how you can accomplish this with the LumenRT extension in CityEngine as well. And in the third stage, basically we also take advantage of pre-developed CityEngine rules for city styles. And that really helps speed up the production and everything else. So when should I use CityEngine to model environments instead of these static modeling that I traditionally use? Well, with 3D, we run into a commonly occurring problem. It's very time, labor, and cost intensive. The process of modeling is tedious and repetitive, and creating modelations is time consuming and extremely difficult. The solution to this is procedural modeling, and that's why we've developed CityEngine. And if you're only modeling a few buildings, then it's easiest to model them by hand. But if you're modeling several buildings, a district, or even an entire city, then procedural modeling is the way to go. With procedural modeling, basically you save that time and money as we just discussed earlier. So can take existing data. So now I'll talk about creating a real city, and then we'll show you fictional city in a little while. So take this existing 2D vector data from the real world, and it can convert it into a 3D within a few simple steps. And I want to go through these steps really quickly with you. So step, we basically take in a geodatabase of 2D information. This could be CAD data, basic vector data. It can come in from Illustrator. Whatever you may be creating some 2D vector shapes in, you can bring them in. Step 2 is creation of 3D streets, blocks, importing of those, and even subdivision parcels based off of street networks to recreate a city or create a new fictitious city. Using procedural rules in step 3, CityEngine would then help to automate the 3D extrusion process of the shapes. So that's just creating like a massing visual to get an idea of what the form of the city should be. In step 4, texturing occurs, and further structural detailing is applied to the buildings. So we start to add to the tops of the buildings, such as air conditioning units, maybe some more better defined windows and other items at that point. And then step 6, you then export your 3D city model to your 3D application, rendering program, game engine, or even you can share it online using our new web scene technology that we've just released for sharing communication and collaboration within your organization for those demanding projects that need feedback. So in even simpler terms, this visual shows the process of extruding real 2D city data into a smart 3D city model. And this is an image of Rotterdam, just to kind of give you an idea of what that map is. So now let's talk about importing data into CityEngine that we require to create a 3D. Well, what you'll find with CityEngine is a general pipeline of procedural geometry generators. Input assets and geospatial data if you have any, and then there's an output, basically 3D model generated procedurally by rules or code. So the figure above, if you want to glance at it, basically gives the import and export capabilities the CityEngine has, which basically includes some of the most common industry GIS and 3D formats. And if you're using CityEngine and use another format that we don't provide, please let us know because we'd like to implement that as well in the future. CityEngine is a complete city modeling suite, and the key to its success is its modeling core that allows for rapid creation of 3D cities. When you move a street or building in CityEngine, all the geometries adapt to the changes. Street modeling tools enable anyone to quickly create streets by hand or from existing splines or even network data that you've imported from the real world or Illustrator for your project. Since CityEngine is geolocated in nature, so it can be content aware of an actual world place, create or import into the system remembers their real world coordinates, making it easily interoperable with other geolocational systems for real cities. So you may be wondering, how does this technology work? How does it do the splitting or the creation of geometries really quickly on the fly? And how does this differ from hand modeling? Well, with hand modeling, you'd have to create all the geometries. With this, the computer does a geometric creation based on the rules that exist, which are CGA rules or shape grammar. You can set options such as the maximum distance of the buildings from the street. Let's say that would be a setback operation for cities. You can set the distance of buildings from other buildings, and even the layout and form style, and even the character of the buildings can be specified on the fly by flipping switches within the rules that we'll show you in a second. The image on the bottom left is a general parcel subdivision scheme created by TU Lisbon and a professor there. And the right kind of demonstrates if that scheme was implemented on that location, what it would look like in 3D. So it's just a few ways of looking at representations of urban form and how these can be used for CG. The cruciform skyscraper slide is another example. This is created by an architect, Le Corbusier. And what we've done here is given you the idea of how CityEngine subdivides and places items or shapes procedurally. Basically, the first step of this process you would name the individual elements of the design. For example, we choose to name core, spine, wing, and tooth for the mass model, as you see in that image on the slide. And after the components have been identified, their spatial dependence has to be analyzed and formalized. So often it's clearly obvious how they are assembled. For instance, element is repeated along the wing in our example here. In the second step, the important the design have to be identified. It is recommended to basically declare these parameters as control attributes in the rule set. So the box shows on the right what these attributes would be for creating a model of this cruciform skyscraper. And building height, number of wings, other elements can then be changed and manipulated on the fly, and you can create a lot of different geometry using one rule that you've created, and that's the power of procedural modeling. So CityEngine develops facades by splitting the geometries, and this image below gives you a kind of idea of how you'd create a row or a Grecian type temple, and how that subdivision actually takes place on the whole object. But as far as a facade or the front of a building, the image here gives you an idea of how it does its splitting process from left to right. Assets can also be imported and placed within the facade, such as 3D doors, flags, and other items to save you from having to manually place those on a model during your pipeline process. So we can create a lot of different types of roofs, such as HIF roofs like gable, gambrel, mansard, and these can be flipped with switches on the fly. And then you can also create modern flat roofs and scatter assets on top of those as well. Heating, cooling, AVAC, you name it, can be placed there. But not only can we do rule-driven building construction and creation, but we can also use existing 3D assets to create the form of the building. So this example, we have several assets that were created by, or they can be created in 3D Studio Max if you have that or another program. And then we can write a rule or use an existing rule with those to create a futuristic city or strange architectural forms that are not traditionally found within the real world. So what I'd like to do is go ahead and just dive in and give you a quick demo of CityEngine and how you create a 3D city model. So when you open up CityEngine, you see this welcome wizard, as you see here. Before we start this, if you haven't tried CityEngine yet, you can go to esri.com or search on Google for CityEngine, C-I-T-Y-E-N-G-I-N-E, one word. And you can download the free 30-day trial to test it out. And once you download the trial, you'll see this welcome wizard here. It kind of gives you an introduction to CityEngine. It lets you set up a default how you want to navigate in the software, so it can help to fit your workflow better. We also the resource library, and I'll get to this here in a little while. It's a robust library of everything you need to get started with in tutorials, training videos, you name it, it's all there. And then you can even download some latest example projects here by clicking on this link, or you can download them off of that resource center that we have. Constantly updating these example projects to make sure that you're successful through your city creation process of creating to different cities from whatever you can imagine. So with this wizard, let's select a project name. So I'm going to call it City 1, just to give it a name. Just choose small so it'll open really quickly on your computer. And I'm just going to call this Scene 1. You can also keep the default settings. And just click Next. And you can choose a specific street layout that you'd like for this example. So let's choose something like San Francisco. And there's several different styles that you can choose for how the buildings should look that are created in the scene. Two of the top ones I'd recommend are the Textured City by Night or the Textured City. Let's just select the Textured City. And then what's going to happen in the back end is CityEngine is going to create this 3D model for us. So just give it a couple seconds as the wizard generates the city. And what you'll notice is the city procedurally grows over time, and you'll notice that each one of these buildings is slowly growing. And that's how this works when a rule is applied to an object and generated in CityEngine. So navigating is very easy. There's several hotkeys that you can find on in the help settings file or on the resource center. There's other documentation on it. We can use the track tool to kind of pan around the scene. We can rotate using these tools, or just buttons on the mouse by holding Alt and moving the mouse buttons. You can zoom in and out of the city as well. So what I'm going to do is I'm going to select a couple buildings here in the downtown area, and I'm going to frame them. We have all sorts of different hotkeys to speed up your design process. I'm going to select this building right here, kind of zoom around it so we can all see it. Okay, so let me maximize my rules, and what I'm going to do is change the height of the building using one of these procedural rules. So what happened is it automatically applied the rules to all the shapes that were generated in the wizard. But usually you'd have to apply those yourself. So I can change the height factor of a building. It makes it shorter or taller. So you can just type it in or use a slider. We can change that building to nighttime or daytime. And then we can even change the building style. And it adapts on the fly to changes. So you can have a bunch of predefined styles that can change on the fly. That's just one of how you can be successful with CityEngine. So another thing that you can use CityEngine is drafting out new urban layouts. So you can use the drawing tools for street networks and create a new, and it's going to automatically subdivide the city and place buildings within that area. But you don't have to just use trace functionality. You can even use these snapping-based tools for streets to draw in existing geometries, and it automatically subdivides these parcels in the city on the fly, as you just saw. So I can even select, let's say I want to pull one of these points. I'm going to raise the terrain a little bit. And as you notice, the city adapts to these changes, and the streets move, and everything adapts as well when I move. So now that I've shown you a quick overview of what you can accomplish with CityEngine, Wizard, and some basic settings, I'd like to open up a couple of other scenes. So I'm going to open up this project for a downtown damaged or destroyed city. And this gives you an idea of how you can create destruction using sliders as well. So not only can we create cities, but we can also have sliders and preset specific rules to where we can choose how much damage a building, what it looks like after some kind of a catastrophic event. And as the city loads, you'll start to see how the destruction can look. It's taking a couple of seconds. Okay, so what you're seeing is this destroyed city, and I'm going to zoom into here. And you'll see that there are defined rules for damage. So we can change how much to offset the damage in the scene. And I can say that I want it to have more or less damage, and it applies it to the side of the building. Zoom in a little bit more. And then I can even offset the damage in the front. And all these rules can be applied in this way. I can even change colors, depending the rules like that, red to white even. When the building changes, I can change tile spacing of the building's geometries. So all that adapts, and even the kind of styles that are predefined for these buildings. I can generate these on the fly and quickly. But what I can also do, is kind of interesting here, is I can also drag and drop rules from other scenes into this city model. So if I select some parcels here, for example, and I say that I want to take and drop this medieval cities rules in here, it will then generate medieval city buildings within that scene. So you can do a hodgepodge of different styles and test out different buildings from other rules to help you to create a city efficiently and quickly for previs or for even final production purposes in certain cases, maybe for mid-ground and background buildings. So that's just a quick overview of CityEngine. Let's go back into our presentation briefly, and then I'll give you another demo of our new web scene export capabilities. Okay, so let's quickly go over some of the pipelines CityEngine utilizes and see how it can fit within your current workflow. So as you mentioned earlier, CityEngine supports the export of 3D models into several industry-leading formats. These are collage, EX, object, mental images, you name it. We can even take things out to other applications such as E-on Software programs, with LumenRT or View as well. So high polygon counts become less and less of a problem due to today's graphics hardware. And depending on pipelines and in the application, the usage of instances is strongly recommended. However, I wanted to note that it might conflict with point 3 here on the slide. High object counts in most 3D editing tools. Each instance is handled as an object, even if the geometry is shared. And as a consequence, we have hundreds of thousands of instances that may heavily affect the performance of such tools, and they're hard to manage. Object counts could be avoided by merging objects with the same materials, therefore depending on the pipeline and the end application again. It is sometimes recommended, though, to kind of expand these instances using their vertexes and coordinates and merging them in a few objects. However, as a consequence of this, local coordinate systems of the merged objects are kind of lost. So high material counts have to be avoided generally, and that's what we recommend for CityEngine. Procedural operations such as this, for example, where we set thousands of materials, diffuse and randomized operation calls where panels are set with a random number, have to be avoided. Instead of this, we recommend using discrete random values where only 10 different materials will be generated. So basically, limiting the number of materials and really optimizing that stuff is what's important with using procedural workflows for cities. And generally, textures from photos lead to more realistic looks and should be used whenever possible. And these figures, the figures here depict possible levels of detail strategies. So as you get an idea, you have a boxy or model of a building, and then you have another switch which allows it to be a medium level of detail, high level of detail, and an extreme level of detail. And using these predefined switches, you can set mid, foreground, and background buildings really quickly and efficiently with CityEngine. Python can be utilized to write proprietary files. So this is accomplished by taking non-instanceable geometry, such as pre-developed asset models, and running a Python script which automatically places the geometry pieces together to form more complex city geometries. This form of instancing works best for fantasy and sci-fi cities, specifically for film and gaming. And it doesn't give you that procedural ability to use a slider to change the height. So it's just taking the instances you've already pre-created. To procedurally distribute and position these model assets, ratios and scales kind of have to be taken into account, though. And procedural generation, for this case, consists of selection mechanisms deciding which assets to place, like I mentioned a second ago, where they're not as driven by the height of the rules and other elements. So tools allow for the simple generation of complex and material networks using different UV sets, mixture coordinate layers on geometry. And however, these material exchange capabilities, industry standards formats are still limited, and furthermore, not many formats are supported by multiple UV sets. In case complex material setups are generated, it's therefore recommended to export the output geometry in the native format of the targeted 3D application. So if you're using 3ds Max, Maya, try to use their formats when exporting out. If this is not possible, then we recommend Claude FBX formats, and I really recommend FBX if you're not going to use Python as scripted export because it loads the best in most other applications. So the last thing I wanted to mention is web scenes. CityEngine can create web scenes, and they can be published online and shared within your organization. The 3D city models you create can be commented and marked up by your team or by other people in charge of the projects. And I'd like to give you a brief demo of these web scenes. So what you saw earlier was this basically destroyed city and showcasing damage and destruction. And what I can do is I can select specific elements in the scene I want to share. I can go to File, Export Models, export it to one of the many formats, but in this case we're going to export the model to a CityEngine web scene. And I can go through this export process, and it'll export in a WebGL viewer to where I can share and communicate and collaborate with other people in my organization or group. So let me show you really quickly what it looks like. So when I export this web scene, I can preset bookmarks, we can play through it, fly back through it, and you can visualize all sorts of other things on the fly, kind of drive where you want people to look and exactly what the demo that you want people to see is. But you can also do a lot of analysis. So if this is a real city, we can maybe look at shadow impact studies where maybe we want to film or something else of that nature. And Esri has other 3D GIS tools that can actually analyze and assess where you should place cameras and other items for a film in the production stages to really help to speed up the filming process. So we can also create, take the other rules such as the fantasy cities and export them as well, such as this example seen here. And what's great, those comments that you saw earlier, they're all located exactly where you look and make a comment. And other people could be notified if you make a comment on their web scene. This is just a quick idea, a quick overview of CityEngine and the web scenes. And it contains information so you know exactly what the shape of that object is in the product that you need changed if somebody makes a comment. So I've quickly gone over export capabilities that CityEngine has. At this point, I want to hand the presentation over to David Burdick from Software to speak about LumenRT and how it can be used in tandem with CityEngine to accomplish realistic urban environments.
Thanks, Jeff. So let me get my things set up here. Is my screen being shared here?
All right.
Okay, so I'm going to show my screen. So good afternoon. My name is Dave Burdick. I'm the Vice President of Marketing with E-on Software. I'd like to welcome you all here to this very informative webinar and thank our host, Brad over at Motion Media, and Jeff Taylor. So what I'm going to do is to walk you through a tool called LumenRT, which we introduced about a year or so ago, and show you the plugin that we developed called the LumenRT GeoDesign plugin, which works directly with CityEngine. And what LumenRT GeoDesign does is really allow you to take all of your designs within CityEngine or other CAD tools and really breathe life into them so that you can tell very engaging and compelling stories. So what I'd like to do now is to actually give you a short video of the technology, and then I'll go back to the slides and then give you a quick demo. I'll put the sound down here. So keep in mind we're watching this over the web, and it's you're probably seeing some chop on it, but I can assure you in real life it's not choppy. So we're showing a scene here right directly inside of CityEngine. We're populating it with trees using our digital nature library, and now we're seeing it in the live cube. So these are actual real-time screen grabs taken directly inside of the LumenRT live cube, which I'm going to show you in a moment. All of the trees and plants are fully breeze animated, so they move. You can add cars and moving vehicles. Also people and characters and animals, and scatter them throughout the scene to give it more life. We've got some nice sky, cloud, and water materials that are fully reflective. One of the really cool things is that you can do night scenes directly inside of CityEngine, so you can add street lighting and then switch lights on and off, do lighting studies, time of day studies. And one of the coolest things is that you can actually package these things up into what we call live cubes and actually share these immersive experiences with other people. So not only images and videos, but the complete immersive experience, and do that directly on their computer. Okay, so that's our video. So let me quickly jump back in here into the presentation and just sort of walk you through a little bit of what LumenRT is all about. So basically, we started in this. As many of you know who are in the movie industry, E-on Software is highly regarded in the media and entertainment world as the sort of go-to solution for natural landscape environments. So we have a flagship product called View, which is used exclusively in the broadcast and entertainment industry. We've been used in thousands and thousands of blockbuster movies and videos. We started a few years ago to re-examine the marketplace and to take our technology over into this sort of real-time design world, and we introduced the product LumenRT about a year or so ago. And really what immersive nature is about is harmonizing the design world, the things that you guys do in terms of designing your buildings, your structures, or your sets, and then harmonizing that with the natural world around us. So we add things like trees and plants, people, cars, nice lighting and skies and water. So we breathe life into the scene. So effectively what you can do is you can transform designs like this in CityEngine into these very high fidelity, real-time scenes such as what I'm showing here on the screen. So there's basically 4 key elements to the immersive nature solution that we offer, called light, life, nature, and design. So under lighting, we offer full day, night lighting, so you can do sunlight, moonlight. You can also add artificial lighting like point lights and spotlights. For the life element, you can add cars and people, and these are fully animated, so you can move the vehicles in a predefined path or add your own animation paths. On the nature side, of course, you can use E-on's very highly regarded plant libraries. We have a library of over 100 plants and trees that you can use directly inside of CityEngine, and when they come into LumenRT, they're fully animated with breeze motion. And finally is design, so we interface not only to CityEngine, but we can connect into SketchUp, MicroStation, Revit, and several of the other media packages like 3D Studio Max. So as I mentioned before, we have a very nice set of integrations. The integration is seamless. It works directly inside of the interface. So for example, inside of CityEngine, we've actually developed a rule base that you can take the LumenRT elements of trees and cars and people and then wire those rules directly into your CityEngine scenes, flick them on and off, change the look of these things, randomize the appearance. And so very quickly, in just a matter of minutes, you can go from a very, sort of lifeless looking urban landscape into one that's completely full of life and trees. And I'll walk you through how to do that in just a moment. One of the things that people really like about LumenRT is that it comes with a very, very large natural scenery content library. So as I mentioned, we have about 100 plants and trees. We have a whole library of people and cars and trucks and motorcycles and boats. And then, of course, we have a very extensive material library that can extend the materials that you use directly inside of CityEngine. One of the really nice things about LumenRT is that you can create your own guided tours and animation. It has a built-in animation editor that's extremely simple to use. You basically just walk around inside the scene and you hit the F6 key to take snapshots, and those snapshots become keyframes, and then you can adjust the timing between the keyframes and add and remove keyframes. It's very simple to do. One of the things that people most like about LumenRT is the ability to do lighting and time of day studies. So it's a fully dynamic lighting capability where you can set the time of day. It's fully geosynchronized with what you have inside of CityEngine, and you can, of course, add point lights and spotlights and luminous windows to create very nice night lighting scenes or sunset scenes. And then finally, last but not least, is the ability to share your experiences. So, of course, you can do images and videos, but the thing that people most like about LumenRT is that you can actually share these things we call live cubes. So you can think of a live cube as sort of like a 3D PDF, and you just basically take these and you can FTP them or even email them if you have a larger email. A live cube is generally anywhere between 50 megabytes to 150 megabytes. So normally you FTP them on a Dropbox, and then anybody can download these live cubes and run them on their machine on a PC or a laptop, as long as they've got a relatively modern PC or laptop that has a decent graphics card. You can run these things, and then they can actually experience the same things that you've authored by walking around and navigating and exploring directly inside the live cube themselves. So that's it. If anybody's interested, of course, you can go down to the LumenRT website at www.lumenrt.com and actually download a trial version, which is a fully functional version of the software. So let me now switch it over, and I'm going to show you exactly how this works. So let's bring up CityEngine. So here's a CityEngine scene similar to the scene that Jess showed you. It's a smaller one here, so I just want to give you an idea of what this looks like. So here's a scene with some streets and some buildings in it and not much life. So to add the life in here, all you need to do is to switch LumenRT on, and then you'll see all these trees and other kinds of things appear. So you can add trees, you can add vehicles. If you go over here, you can see things like people and lights. And it's extremely simple to add and change things. So for example, I can go over here to this lot here, and then I want to say I'm going to change it. I'm going to put a parking garage here. So I go over here and I'm just going to go select a parking lot, say OK. Or I could change it to a let's change it to a garage. I can find it. I don't see it here. Or a tree-lined border. So I can have trees bordering it. I could change it into, let's see, what else do we have here? A tropical park. So here's a park with tropical trees, and then of course I can randomize what these look like by doing a Control-Shift-G, right? So I can just hit the Control-Shift-G and then just change it, and we'll randomize the seed and change the look of these. And let's see what else here. Here it is, parking garage. So now I've just changed that tropical lot into a parking garage. So this is one of the real powerful things about CityEngine is this procedural modeling, is that once you have these rules created and baked in, you can really, do some really interesting what-if scenarios and change things very, very quickly. So let me change this thing back to a pine lot, pine park. Okay, so now I have a pine park, and then to export this, all you need to do is you can select whatever things you want, and then just say export to LumenRT, and it just takes that and grabs it up, and then you have a little interface that pops up directly inside of CityEngine, and you can adjust the kind of sky that you want. You can change the background there, and you can adjust the quality. For most purposes, a draft or standard quality is all you need, and then you just hit the start button and away it goes. So let me bring up this scene here so you can see what it looks like inside the live cube. Okay, and I'll take this down. So now you should be able to see the scene. So now I'm inside the live cube, and you can see the motion. Hopefully it might be a little choppy. But you can take this and walk around. If you move in, you can see that there's characters moving, cars moving. You can see that the plants are moving. If you want, you can actually go into what we call walkthrough mode by hitting the F3 key and actually walk around at eye level directly inside the city. Watch out for that truck. Okay. Another really cool thing you can do here is you can actually, let's page up here. So I'm going to create some keyframes, and it's very simple to do. You just hit the F6 key. It takes a picture and then creates a keyframe. Then I go back. Let's do another one. Take another view over here. Hit the F6 key. And then now I'm going to play the animation. So I just go over here, and then now I've just created an animation. Very simple to do. If you want, you can actually edit the animation. You can go into the animation editor and then change the timing between here. Let's make this 5 seconds. I can actually go in here and then walk around and add keyframes. So I just add a keyframe here. So now I've got a new keyframe, and then I can just animate from there. So you get the idea, right? Now, one of the other really nice things, as I mentioned before, is you can do this thing with lighting. So let's back up here and we can see some lights. Change the time of day. So by just hitting the G and H keys, I can change the time of day. Okay. And then if I want, so now you can see the time of day change, and if I want, I can actually put the switch on the street lights, and then move to a night scene. So now you can see the scene at night. There it is. Okay, and now I can make it a little darker. Let's go later in the day. There you go. And there you have your night scene. So you can see that the windows, it's got luminous windows on there. You can see there's street lights. We actually even have lights on the cars, so when it's at night, you can see the lights shining from the front of the car. And so that's it. I guess what I'd like to do now is turn it back over to Jeff and take it away. Let's see. Undock. Okay. Okay, screen sharing. Change presenter. Jeff. Okay. All right, Jeff, you're the presenter.
All right. Thanks, David. So hopefully everyone, the great stuff that E-on Software is coming out with LumenRT, I think is pretty phenomenal, and it definitely adds a lot more to our city creation workflow and the ability to actually visualize realistic with things animated and moving throughout them. And it's another great way to share cities and collaborate within your team organizations. So let's go through the road ahead for CityEngine in the 2013 and quickly disclose what's coming this fall. So for the 2013 release, we have added the ability for anyone to encrypt engine the rules that they write. So the rules that you basically saw David messing with earlier, or myself in the previous demo, those can be encrypted to where only you are able to edit those. So people have to come back to you and pay you for the service of creating city creation rules. That's one cool thing that's coming out. We're also going to be releasing a software development kit, an SDK, which I'll speak about next. And the other thing that we're going to do is push some drastic street improvements with parking, bike lanes, all sorts of new street import capabilities for added realism into the CityEngine product. And that's all coming here. So what is this SDK that I was just talking about? Well, the use of this is basically to proceduralize your in-house modeling pipeline. So we have an artist that basically would write the rules, or you can use the existing rules that we're creating or other people have and we'll share maybe on our Esri marketplace or share online. And you can implement those within CityEngine application or within the SDK from your 3D software design package. If it's Maya, 3ds Max, whatever it may be, you can actually run CityEngine rules with applications now. And the outcome is basically your film, your digital urban sets, and every streamlined in your pipeline. So here's a typical use case. So we have 2D data. This could be real-world geospatial information for footprints of buildings or streets or information. It could be vector objects you've driven or you've created in Illustrator, AutoCAD, even your 3D modeling program natively if you've created it in there. And I'm going to give you an idea of how this actually works. So the rules applied, and the buildings could automatically generate, or the streets could automatically generate in your program. So let's play through this quick demo of our new SDK inside of Maya. So you can draw the shape, you can apply the rule to the object, and it's procedurally going to generate this building inside of your 3D modeling application. You can also select several other things, such as attributes for the building from the rules, and those can drive further generation. So everything adapts on the fly to the changes that you make. But not only this, once you've drawn a footprint or a shape, you can then further refine the iterations of this shape. And we'll show you this here in a second. And that same rule that you've applied stays attached to this footprint of the building throughout the modification process. And voila, you've got a different formed building with the same exact rule and same exact style applied to the footprint. So that's just a quick demonstration of what's new there. Let's see. Let's go to the next slide. So that was the SDK. We're releasing several new street improvements. We have a for the real world, really, for urban planning and design called the Redlands Redevelopment Toolkit. You can find it on the Resource Center or under our case studies page under the CityEngine website. And with this, you can create fairly realistic cities and actually get metrics if you're an architect or engineer. But you can also use that for other sorts of applications, such as film or games as well, if you want to have that specific look and feel in your application. There are also several new updates with the streets, such as when we import street networks, whether it be vector log or whether it be from OpenStreetMap or a geodatabase from a real city, they automatic collision detection. So a bridge knows where it needs to be, and it doesn't automatically intersect with the streets. And that really helps to speed up the data cleaning process and the 3D modeling process. And that's been a real pain in the past, and we've now resolved that. So we also have improved our abilities to fit curves to a graph. So basically we can interpolate where there's a lot of points along the spline and really simplify those geometries to help to optimize basically everything to go into your pipeline so that you don't have all these extra geometries that are unnecessary. And the last piece with this, we've added the ability for, if you can see it in this bottom slide, if you have parcel data or building footprint data and information, we can automatically, with a new option in CityEngine, extend the streets to the edge of the adjacent geometries. So it really helps you to not have to, model things by hand anymore as far as streets go, or manually manipulate things. And then the last street update is an automatic height fitting for all streets when you import from OpenStreetMap. And the reason OpenStreetMap is it's freely available streets for almost everywhere in the world. And this can really help you with recreating existing urban forms, or if you're creating a futuristic city, just steal a city intersection from, another city somewhere that it's the style you need, and there you go. It saves you the production time. So, and what are we doing? Well, several things. At Esri, we're constantly making it to improve the user experience, as seen here. So we're adding multi-patch hand modeling tools into we did so last year, and we're further updating them with the next release. We're also improving different things within our pipeline to make you more effective and much more efficient with your current work, such as the SDK, which we'll be releasing this fall here within the next couple of months. And again, I'd like to for joining this webinar. And if you'd like to learn more about CityEngine, visit CityEngine. You can download the free trial there and kind of let us know what you think. And I'd also like to thank David Burdick for joining us from E-on Software. And if you want to learn more about LumenRT, visit www.lumenrt.com. I guess we want to open it up for questions.
Yeah, it looks like, hey, Jeff, it's Brad at Motion Media. Jared asked, I mean, this was from a while ago, but there was a section of the demo where road textures in between buildings where parking lots or grass should be.
Okay.
He just asking, how would you fix that?
Okay, where parking lots or grass should be.
Well, there was like road textures in between buildings where parking lots or grass should be. I'm not exactly sure which part of the demo I was talking about. It was a while ago, but
Yeah, what you could do is just pull. You can then basically switch it out to maybe. I think what happened, there was probably a shape where there were parking lots that were proceeded. You could then drag a rule for creating a forest or creating a park or something else in place of that, and that would automatically fix that that situation. As everything is rule driven, if you have a shape, just apply something else to the geometry, and it automatically adapts.
Okay. There was one other question about being compatible with CryEngine.
Okay, yeah, currently the SDK, we don't have a way that it's written to connect to CryEngine, but what we are offering once you release it, that Maya integration for the SDK will be able to be coded to fit into your game engine of choice. You can actually develop that or program it to streamline, or you can even hire a consultant to do it, or over time, if we have enough interest, we can then develop that as well, a connection there. You could do the same thing with Unity as well. What I'd also recommend for CryEngine, if you can take FBX, which is probably our best export out of CityEngine, or use the Python scripted export from CityEngine. That's another really beneficial. And a lot of the entertainment groups we've worked at, such as Pixar and other companies, have been using the Python export to optimize their workflows further.
Okay. Let's see, Carl is asking, incorporating real-world parcel geometry is still quite difficult. Are there any plans to expand on the Python script that aligns parcels to streets, like the fit?
Yeah, actually, the parcel to streets capability, I wish I could show it now, but it's still kind of a beta, but it works fully. What it will do is take the parcels you have, and if you have a street center line in the middle of those parcels, all you have to do is go to File, Segments, like where the lines are, and there's an operation that you can run, as I showed in the. Let me see if I can go back to it. Right here at the bottom, fit streets to width to the shapes, and it'll automatically that street network to the edge of all those parcels, and it really helps to speed up that process. Now, the other thing that we're going to be releasing is the ability to automatically set the first edge of the parcels that are static in nature and have those face the streets. Now, then you saw we also have automated parcel subdivision if you have a street block or the streets are completely in. And then you can use those to create parcels as well, and then that way everything's watertight. But with real typical the issue is always lining up that information, and sometimes it still requires a little manual oversight. But in most cases now with a fit street widths to shapes operation, there's very minimal manual oversight that you need to have to do for modeling, I don't know, a few square kilometers fit.
Okay. Ricardo's asking, what are the advantages of using FBX over to import models over other formats?
Okay, so let me see if I can go back to the slide with some of the import formats that we currently support. Oh shoot, it's not wanting me to go back to it. Jump up. Sorry guys. Okay, so what some of the benefits are is it retains the textures the best of any of the unless you're going to use the Python scripted exporter to fit your exact pipeline. The mental ray reality server works fairly well for preserving some of the textures as well based on your application. And then the massive exporter for collision detection of people within scenes. Object and Collada are not going to retain the textures the way that you may need them for production level work in certain cases, just because of the nature of those two exporters. But the FBX will help, and maybe there's a translucence variable or something else within the 3D city models.
Okay. Raphael's asking about Esri base maps. Do you have any plans to add that function?
Yeah. Currently, we're working towards having dynamic imagery be able to load inside of CityEngine, and it be another release before the dynamic layers will be loaded in. But over run, this stuff will be put into basically our 3D globe service systems as well, so you'll be able to load your models on 3D globe or into the existing web scenes like we currently have available. There are services that you can use if you want to process them with our product ArcGIS, and there's a 60-day trial online for that. So that product's ArcGIS Desktop, and those are called data maps, D-A-T-A space maps. A lot of street data we have available and other imagery and different things for the United States that you can use there as well.
All right. Does anybody else have any other questions? Let's see. The envelope tool proved to be very helpful on a recent project. One addition I'd like to see would be the selection of the world north, world south to apply the base height angles, etc., instead of street.front and street.back. Most height to boundary rules work regarding a cardinal direction.
Right, yeah, currently it's all based off of directional information, the way CityEngine works. The limitation is one building doesn't know what the other building next to it accomplishes. So if you know what the front of the building is, you can then know what the back is, and you still have to basically specify what the front face is versus the back. And if you know what the front is, you know automatically what the back tends to be. So there's no real way to deal with that basic situation that was asked.
Okay. Looks like that's it on the questions unless we get another one. Jared just says thanks. You're welcome, Jared. All right. Well, I just want to, again, this is Brad from Motion Media. Just want to thank everybody for coming. Thank you, Jeff, and thank you, David, for presenting. And I'm going to send out an email with the recording of this webinar, as well as maybe a special little promo for the attendees. So watch for that in your email address. And thanks again. Have a good day.
Thank you. Take care, guys.